Okay, let's go in a bit of the depth of the functions available in this program. Okay, let's load some image which is a not very good quality. For example, let's say this one. We have some letters on the bottom, we have some shadows, there is some letters over the detail, and for example we want to cut only that heart with that horns and the tail, and that's it. But someone just put something on the picture. Of course, that's a pretty common. They're trying to uh, lock the images. You need to register on that website to download the full quality or something like that. Anyway, you have this picture from the internet and you want to turn it very quickly into a program for a wire cutter, and there is some damaging details on it. Okay, let's try to fix that. We're going to our settings, and as we see, there is some details. We can just switch on, switch off, regulate it. By detection level, manipulating the detection level, we can just avoid these little bits because they have some color. And normally, at this moment, I go closer to the white. And at this moment, they just disappear. We can go higher and we can see exactly other edges. But normally, always there is some sweet point on most of the pictures, which we can just pick up like that, and that's it. Of course, to remove that from the bottom, we will need to edit that or just cut the image to the size of that, but I will not show how to edit images in some graphic programs. I will just show the details or the settings of the program. Okay, and now we can just compute, and we have the image. We can go into edit, and we can create a Beziers. This oversampling, less oversampling, then more Beziers we will generate. The shorter Beziers, we're going higher with oversampling. Less Beziers will be generated, but then the precision of editing will drop down a little bit. Okay, and that's our angle of the Bezier. That means if the lines are changing more than 15 degrees between one and another, then the Bezier is generated on them. Okay, let's try and do that, and you see how the algorithm just works. It's not perfect in all the places. For example, here it didn't generate very well to the edge. The same in a few other places is not very well. We can just change that picture to be a grayscale, switch off the clipping, and start editing, because we choose to go with a Beziers, not a fast generator, but just a Beziers. We are allowed to edit them, and as you see, we can just manipulate the edges of them. Or we can just deselect and just go with a manual replacement. I will just now select lines and Beziers. For example, I will regenerate all this image from this point to this point by just one single Bezier. I will just click merge, and all of them will be merged by the single Bezier, single line. Edit, and now I can just use the control points to just, as best as I possibly can, recreate the edge of that. Okay, the same here. I will select some Beziers. No, this one is okay. I will just edit it. Okay, and merge again. Okay, and in this way we can just regenerate whole picture, or we can just use edit and try to fix the mistakes of the algorithm by just changing the position and the shape of the Beziers which the algorithm just generated. Okay. Of course, more time we will spend on each project, then the project will just look, the cut will look much better. Okay. There is a little detail which did it. Okay, and roughly that's what I want to achieve. And now I can just again move it to the point where I want to start. Okay. I can generate a mirror of that. I can just, for example, just generate a mirror of the heart itself if I like to. I will just select all the lines on the heart. And for example, I will just mirror just this little part. Okay. And the same, I can just mirror other parts, or I can copy them. Just to best use the material which I have. Okay, that's it. Now I can just go to a CAM module and do exactly the same Let's generate the wire path. Okay, let's simulate it. As you see, the green lines are moved only once over. The jump points move always twice. That means going into another detail, another loop, and going back from that loop. And that's simply it. We can just save it or send to the machine directly. Okay, let's go into some more detail. Again, we have some more complicated image. Let's pick something a bit more complicated. Let's say the dragon. And when you go to a millimeter pixels, you see the image originally is much bigger than the material. It's a 770 millimeters. The material is just a 400 millimeters. We can force it to just be to the material, to the size of the material. But then we're just using a much less pixel to regenerate, or much less space to regenerate. If there is some problem with regeneration of the edges, of course on this one shouldn't be any, but if there is, you can just always size it up, the image, to a much bigger size than the work material is, because like I said, the work material is just a virtual. And now use this picture. As you can see, there is some defects by the compression of the JPEG. There is some artifacts or some rogue pixels around, and some pixels are pretty close. Anyway, this algorithm on this condition should still generate pretty good outcome. And as you see, at this moment there is some connection here. There is some very close points, some loop in a wrong directions. We can go into a setting and then adjust the detection level. As you see, there is no connection here. Everything is looking like it should look like. You can just switch on the background and see there is a really connection. That would be very hard to eliminate because there is a black color. That means there is nothing a part of that. We need to switch on edit mode and then cut that out, because the picture itself is still very small resolution to regenerate, and it have some not very well colors on the edges. As you can see, there is a lot of white pixels inside, but still algorithm just generate the edges almost correctly. Okay, and we can click compute. And the thing is, bigger image you will generate, more points you will regenerate from the picture. The algorithm will take constantly more time to generate the path and the lines, because all these calculations are based on the amount of the pixels. Because each time when the algorithm connects two points in a line, it's checking the closest points in a matrix. I mean, if there is a 5,000 pixels, it's just checking from each pixel is connected, and that's why on the end it's just speeding up, because there is a less and less pixels which could be taken in consideration to which it can connect them. Yeah. Anyway, that's it. We have the image. We can just go fast mode, and now we can just again resize it to the size of the material. And that's it. We have a dragon. We can save that file, or we can just click calculate and then algorithm will automatically go and calculate the wire path. Okay, that will be it. I will let the algorithm just finish, or you can just stop algorithm. There is a stop button appearing here each time you start the generation and you want to change something. There is a stop button, you clicking it and it just going to a standard mode, clearing all the settings. Okay, that's it. Next tutorial will be on lasers.